So today we are going to do two very important theorems. The first one is called the midpoint theorem, and then we will do the converse of the midpoint theorem. So what does the midpoint theorem say? That in a triangle, it could be any triangle, acute angle, right angle, obtuse angle, whatever. In a triangle, now as the word suggests, if I join the midpoints of any two sides of a triangle. So let's assume that we are joining the midpoints of AB and AC. Okay, I'm joining the midpoints of AB and AC. So let the midpoint of AB be D and let the midpoint of AC be E. Then according to the theorem, the line joining the midpoints of any two sides of a triangle will be parallel and half of the third side. Okay, and note down this: line joining the midpoints of any two sides of a triangle is parallel and half of the third side. Okay, so what does it mean? That if AD and DB are equal, in other words, D is the midpoint of AB and AE equal to EC, in other words, E is the midpoint of AC. Okay, D and E are midpoints. If I join DE, then DE will be parallel to BC and DE will be half of BC. So that means if, let's say, if BC is 10 centimeter, then what will be the length of DE? DE will be half of that. How much? 5 centimeters. So this is what the midpoint theorem says. The line joining the midpoints of any two sides of a triangle, if I join the midpoints, that line will always be parallel and half of the third side. Okay, so you may note down this midpoint theorem. And then we will go to the converse of the midpoint theorem. Once you have finished noting down this, please let me know that you are finished or not finished.
So done.
Okay. So once you understand what is the midpoint theorem, now we can go to what is the meaning of the converse of the midpoint theorem. So converse of the midpoint theorem I am explaining here now. This is also valid only for triangles. Converse of midpoint theorem. Converse means the reverse actually. Okay, so reverse or converse we normally call converse for theorems. And here what is the difference is that D is given the midpoint. Okay, here D is the midpoint. Here both were given midpoint. This is equal to this, and AE is also equal to EC. Both of these were equal. Here only D is the midpoint, and here what is happening? DE is given parallel to BC. And according to converse of midpoint theorem, if I draw a line from the midpoint of one side of a triangle parallel to another side, it will intersect at the midpoint of the third side. That means converse is that if D is the midpoint and I draw a line DE parallel to any side, then the point of intersection will also be the midpoint. So converse of midpoint theorem is used when one midpoint is given and the other we have to prove it's a midpoint, and midpoint theorem is used when there are two midpoints. So I'm writing down the statement, you can write down.
So sir, in this case, E is the intersection point, so we are proving that E is also a midpoint.
Absolutely right. So from the midpoint of any side of a triangle parallel to, okay, from the midpoint of any side of a triangle, if a line is drawn parallel to any side, then it will intersect at the midpoint of the third side. At the midpoint of the third side. So what does this mean? That if AD is equal to DB and DE is parallel to BC, then AE will be equal to EC. So if I have got one midpoint, and from that one midpoint, if I'm drawing a line parallel to another side, then wherever it intersects on the right, say that will be the midpoint of that third side. So you need to understand the difference between midpoint and converse. Midpoint is used when both are midpoints and we prove that the line is parallel and half. And converse is used when one midpoint is given and we have to prove that the other is also a midpoint. So the next exercise will be using these two theorems, midpoint theorem and converse of midpoint theorem. So you can note down this.
Sir, done.
Okay. All I've written. Can we shift?
Sir, 1 minute.
Yeah. Finished?
Yes, sir.
Okay, so now we are going to use now midpoint theorem and converse of midpoint theorem in the second exercise 8.2. Okay, so let's come to the question. So this is the question given to you. ABCD is a quadrilateral in which PQRS are the midpoints of the side AB, BC, CD, and DA. AC is the diagonal. We have to prove that SR is parallel to AC, SR is half of AC. PQ is equal to SR and PQRS is a parallelogram. Okay, these are the three things. So first thing, what we need to prove is that this is a quadrilateral. So make the figure of a quadrilateral. A quadrilateral, you can make ABCD. PQRS are the midpoints. So put the midpoints here, PQRS, join this. Join the diagonal AC, that's your construction. To prove there are three parts. SR is parallel to AC, SR is half of AC. PQ is to be proved equal to SR and prove that PQRS is a parallelogram. Okay. Have you noted down the figure?
Yes, sir. Yes, sir.
So how do I prove the first part? It is very easy. SR is parallel to AC and SR is half of AC. We can directly say this by midpoint theorem. Why? Because in triangle ADC, aren't SNR midpoints? And what did we do just now in the midpoint theorem? That the line joining midpoints of two sides will be parallel and half of the third side. So they have written the full statement of the midpoint theorem. So the first one is direct application of midpoint theorem. So what you need to do is you say in triangle ACD, SNR are midpoints of AD and DC. Therefore, SR is parallel to AC and SR is half of AC. Reason, the whole statement you need not write. You can just write down there midpoint theorem.
Sir,
Yes.
sir, suppose in a diagram there are two midpoints, sir. Then, sir, which
Yeah.
one would we choose? If there is something to confuse us, then how will we specify that this is the midpoint of this particular figure?
No, here there are four midpoints, not two. Four are there. All are midpoints here.
No, sir, I'm talking about the figure. Suppose there was only the triangle ACD and we were
Uh-huh.
given two midpoints like that. Then I'm asking.
I didn't get you. For example, this is a triangle ABC,
Yes, sir.
and you are having midpoints, two midpoints, P and Q. So what is the issue now?
No, sir, yes, sir, this is one line that is parallel to BC. Sir, suppose we are given one more line parallel to BC. Sir, can a question be like that?
But then that is, it can come parallel, but this cannot be midpoint then, no? The midpoint theorem is only valid for midpoints. You can have a triangle with lot of parallel lines. All
Yes,
these are
sir.
parallel lines, but only one midpoint will be there, no?
Okay, sir.
So this will, all these are parallel, but only one of these lines is half of BC. Which line is half of BC? Only the line which is joining the midpoints. Otherwise, if you take PQ is parallel to BC, but PQ is not half of BC. Because
Yes,
what is
sir.
the midpoint theorem? The line joining midpoints is parallel and half of the third side.
Of the third side.
Yeah, so this half will only come when it is midpoint. Otherwise, if it is not midpoint, it will not come half. So you can prove that they are parallel, but you will not be able to prove that this is half of AC. This half is coming only because of the midpoint theorem.
Okay, sir.
Okay. So first part is clear. Now we go to the second part. PQ has to be proved equal to SR. So just like we took ADC triangle, same way in triangle ABC, now what can I say? I can say PQ is parallel to AC and PQ is half of AC, right? PQ is parallel to AC and PQ is half of AC. So if I compare these two, what is common? AC is common. We know that two lines parallel to the same line are parallel to each other. So what will happen? If I take out this AC out, what is left here? PQ and SR. So I will get PQ parallel to SR, and PQ is half AC, SR is also half AC. So what is the conclusion from here? From here I can say that PQ is equal to SR. Two lines equal to the same line are equal to each other. So the value of PQ is half AC, the value of SR is half AC. So half AC is common in both. So I can say that PQ is equal to SR. Okay. So the third part you will write from 1 and 2. Okay, this is 1 and this is 2. From 1 and 2, we can say that SR is parallel to AC, PQ is parallel to AC. So what is the conclusion? AC is common, so PQ and SR are parallel. Again, from 1 we got SR is half of AC. From 2 we got PQ is half of AC. From 1 and 2, what can we say? Half AC is common, so PQ equal to SR. So that's part 2. And now what have we done? We have proved that PQ is equal to SR and PQ is parallel to SR. So third part, obviously the conclusion will be it's a parallelogram, because if one pair of opposite side is parallel and equal, that figure becomes a parallelogram. Okay, so we are using midpoint theorem here twice.
Sir, can we copy it? I mean,
Yeah, please. Please note down the answer of 1. All the 3 parts are clear, I suppose.
Sir, could you explain the third part once again?
Third part you have already proved in the second part that PQ and SR are parallel. PQ and SR are parallel and PQ and SR are equal. Both these we have proved. If one pair of opposite side is equal and parallel, then that figure becomes a parallelogram. So third part is actually from part 2. We have already proved that PQ equal to SR and PQ parallel to SR.
Okay, sir.
Sir,
Yes.
sir, sir, in the first part, sir, the statement that is given is line segment joining midpoints of two sides of a triangle is parallel to the third and half of it. That is, sir,
Exactly.
they are saying that third, it is the half of the third side.
Yes. Half of the third side. Line joining midpoint of any two sides. So which is your first side? This is your first side. This is your second side. So line joining the midpoint of any two. So I have selected this two. Will be parallel and half of the third side, which is your third side now. This is your third side. So the line joining the midpoints of the first side and second side will be parallel and half of the third side, isn't it? So this is your third side.
Okay, sir.
So this
Okay,
line will be half of this.
okay, sir.
Everyone has finished the first part or still doing?
Sir, written.
Written down. Okay. Now we come to the second one. ABCD is a rhombus. PQRS are the midpoints of AB, BC, CD, DA. Show that PQRS is a rectangle. Now what is given? The original figure is a rhombus. Again, PQRS are the midpoints. We have to prove that this figure that is going to be formed is going to be a rectangle. So to prove that a figure is a rectangle, what we need to prove is that all angles are 90, opposite sides are equal, and opposite sides are parallel. So the proof is the first part is in fact same. For every figure, first you need to prove that the figure is a parallelogram. First of all, you will make the figure ABCD. This is a rhombus. Now you know that in a rhombus there is a very special thing about diagonals. The diagonals will intersect at 90. Now you are going to take the triangle ADC. Okay, same procedure. In triangle ADC, what will happen? S and R are midpoints. So if S and R are midpoints, what is going to happen? SR will be parallel to AC and SR will be half of AC. Right? Then same way in triangle ABC, PQ will be parallel to AC and PQ will be half of AC. All this we have done in the previous question. It's a repetition. From equation 1 and 2, AC is common, so we'll get SR is parallel to PQ and SR is equal to PQ. So what is the conclusion? That PQRS is a parallelogram. So for every question, first you need to prove it's a parallelogram, because once you prove a parallelogram, a lot of things are automatically proved. That means all opposite sides are equal and parallel is already proved if it's a parallelogram. So once it's parallelogram, now I have to prove it's a rectangle. And for that, what I need to do is that prove that one angle of this parallelogram is 90. So that's very easy because this is a rhombus. And as I told you, the diagonals of a rhombus intersect at 90. So this angle here, angle O, is going to be 90. And if this angle is 90, then what is going to happen? The figure that is here, shown here, okay, I'm going to shade this figure here. That is PXOY. What do you think this is? This is a small parallelogram. This is a small parallelogram. Why PXOY is a parallelogram? Because opposite sides are already parallel. We have already said that this line is parallel to this and this line is parallel to this. Okay, I am taking this. Already we know that the line joining midpoint. So this will be parallel and this will be parallel here. So this figure PXOY is a parallelogram, and in a parallelogram opposite angles are equal. So what will happen? Angle P will be 90. And in any parallelogram, suppose I am proving that this is a parallelogram. If I prove that any one angle is 90, that is sufficient for me to tell that all angles will be 90. Therefore, what will happen? If all angles are 90, we can say that figure is a rectangle. Okay, so I'm explaining the proof once again.
Sir, can you explain it on the board, sir?
Okay. So what is the question? First, I'm repeating the question that ABCD is a rhombus. PQRS are the midpoints. So let me draw the rhombus. This is our rhombus. Diagonals of our rhombus are going to intersect each other at 90. Okay, so A, B, C, D is a rhombus. This is what is given to us. P, Q, R, S are the midpoints. So P, Q, R, and S are the midpoints of this. So I'm going to join P, Q, R, S. Now the question is, when I join the midpoints of this, the question is prove that the figure that is being formed is a rectangle. So what I was telling you is that first in triangle ADC, I'm going to use the midpoint theorem. In triangle ADC, what will happen? SR will be parallel to AC and SR will be half of AC. Why am I writing this? I can simply write this is midpoint theorem because S and R are midpoints. Then I will go to triangle ABC. In triangle ABC, what can I say? That PQ is parallel to AC and PQ is equal to half of AC by the same theorem. Now from 1 and 2, what is the conclusion? AC is common, so PQ will be parallel to SR and PQ will be equal to SR. Hence, what is the conclusion? PQRS is a parallelogram. So this is the same as what we did in the previous question. This much is clear? Or any doubt here? If there is any doubt, you can ask up till here.
Sir,
Yes.
sir, hence PQRS is a parallelogram, right?
Correct.
Okay.
PQ and SR are parallel, PQ and SR are equal, so PQRS is a parallelogram. Now we go to the second part, we have to prove it's a rectangle. Now how do we do that? Diagonals are intersecting at 90, so I can say AOB is 90. Diagonals of a rhombus intersect at 90 degrees. So AOB is 90, why diagonals are intersecting at 90? So this angle will be 90. Now what I am saying is that if you look at this small figure here, let's mark this X and Y. I can say that PXOY is a parallelogram. Why is PXOY a parallelogram? Because opposite sides of the parallel of these figures are equal. Opposite sides are parallel. Okay, sorry. So this will be parallel here to this, and this will be parallel to this. So this figure that you see PXOY is a small parallelogram, and in a parallelogram, what do we know? That opposite angles are equal. So angle O was already 90. So what is the opposite angle of O? Angle P here. So therefore I can say angle P is 90. Opposite angles of a parallelogram are equal. And if angle P is 90, we can definitely say this is a rectangle. Why can we say it's a rectangle? Because in a parallelogram, if one angle is proved 90, if one angle is proved 90, then all the other angles will be 90 degrees. So it is sufficient for me to prove that one angle is 90, automatically the other angles are 90. Already we have proved it's a parallelogram. So if it's a parallelogram, opposite sides are parallel and equal. So definitely the figure PQRS will be a rectangle. So that will be your solution to question number 2. Yes.
Sir, I understood all the procedures, sir, but why are we taking only the small part PXOY?
Because I need to prove that angle is 90. Either we have to prove P is 90 or Q is 90 or R is 90 or S is 90. So how will I prove that? I'll have to take one of the portions because I have to make use of the fact that these angles are 90. So either you can take this part or this part or this part or this part. So you select any part. This is the rhombus.
Okay, sir.
We know that diagonals intersect at 90. So you can select any of the 90 portions. I have selected only this, but you could have selected any other. Otherwise, how will you prove that angle P is 90 if you don't take one of the
Yes, sir.
portions?
Yes. Okay, understood.
Yeah,
Sir,
any one
so
portion. Yeah.
sir, after we have taken out P is equal to 90, so sir, we can say that S is also equal to 90, R is also equal to 90, and Q is also equal to 90.
Yes. Why? Because we know the property of a parallelogram.
Yes, sir.
What is the property of a parallelogram? If this is 90,
Sir,
opposite angles are equal to
opposite
this,
angles are equal.
and these angles are co-interior angles. Co-interior angles will add up to 180. So if this
Yes,
angle
sir.
is 90, this will be 90. If this is 90, then this will also be 90. So if one angle is 90, automatically all the other angles will also be 90. So we need not prove for every angle. We just need to prove for one angle. That is why we have proved that first it is a parallelogram. Proving that it is a parallelogram was important. Then only we can say that one angle is 90, all angles are 90. Otherwise, otherwise if you don't prove it's a parallelogram, then you will have to prove that all angles are 90 separately.
Sir,
Yes.
so can you read the line after the line PQRS is a rectangle? After that, what have you written?
PQRS is a rectangle because in a parallelogram, if one angle is proved 90 degrees, then all other angles equal to 90. In a parallelogram, if one angle is proved 90, then all the other angles are 90 degrees. So we are using the same concept as we did in question 1, that is the midpoint theorem.